All right, welcome to another lunchtime video for the JNCIE-SP. Really not going to be working with Junipers or Cisco's professionally for a while, but I'm going to continue to work on this exam because I think having an expert level certification will be important for my career. So I'm going to keep working on this, and I will share my screen. And it's just another 3 months of studying anyways, so if I go, I take it, I pass it, well, whoop-de-doo, you know, that's a really good thing. If I fail it, you know, then I really gotta decide if I want to take it again, because it's going to cost about $3,000 of my own money to take, and just to fail, I don't know if I want to spend another $3,000. So that's the purpose of these videos, though, so make sure I pass it on the first try, even though it's rare for people to do that. But let's give it a shot. So this is going to be the 5th video. Okay, so last video I set everything up for ISIS. We're going to look at how to configure authentication for ISIS, and then we're going to set it up for IPv6 and OSPF v3, and then set up authentication for that, and then we'll be done with this section. Yeah, I'd expected to finish it last night in the after work video, but for some reason I didn't make a after work video. I think I've been kind of feeling a little just a little sick the last few days. Not coronavirus, but enough to benefit from taking a little time off from these videos. But I'm back now, so let's check the configurations. Okay, so I've still got OSPF configured on router 1. So I was basically just demonstrating how to do it remotely. Time is of the essence, so let's kind of not worry about demonstrating that. I've demonstrated multiple times how it can be done through a jump server if you're aware of your source IP. So let's just work as fast as possible and try to finish this topic during this lunchtime video. All right, so it's time to configure router 2, assuming this all goes through. There we go. Let's see if ISIS adjacency came up. And it did, so time for router 2. I'm gonna put on my stylish headphones that I wore in the last video. Just kind of helps me to focus a little bit. So let's see here. Okay, so time to configure ISS. Oh, I forgot address. Okay, so after this commits, let's verify that there are now 2 adjacencies. Oh, and it looks like I've got, aha, so this makes sense. I've got 3. I've got a level 1 adjacency and a level 2 adjacency. I guess I'm surprised I don't have 4, but I guess this is good enough for now. All right. Okay, so this is going to be fine for now. Let's move on to router 1. Okay, so I should have adjacencies to all of the routers now. Oops, it looks like I do not. Oh, and you can see here's the problem. There's an issue with the forwarding plane. So I think I'll just reboot my whole lab. Okay, and I'll be back in a few minutes once this is back up. So pause the video and come back. All right, so welcome back. You can see the forwarding plane is now up. So let's see if we've got ISIS adjacencies, and we do. You still only got one adjacency to router 4, which is interesting. But I don't think that's going to be an issue at all. So let's explore authentication. Okay, so let's look at setting it up between router 3 and router 4 across this link here. Okay, so the first thing I'll do is set up trace options. I think I'm going to need these tip once again. Okay, feel a lot better now. So it's time to set up some trace options. Okay, so let's start monitoring the trace options file. Okay, so probably, yep, we're going to get a lot of chatter here. There were just a lot of flags to look at. Thought we could keep it up going. We'll now set up authentication on one side, so the adjacency is going to drop. And hopefully we'll see a term we can use to filter these messages down. Hopefully the term is something like authentication. So let's use a help apropos to figure out what configuration is required. Okay, so we can see here, although all Junos IGPs support authentication, some are inherently more secure than others. Most service providers use OSPF or ISIS to allow fast internal convergence and scalability, and to use traffic engineering capabilities with multi-protocol label switching, MPLS. Because ISIS does not operate at the network layer, it is more difficult to spoof than OSPF, which is encapsulated in IP and is therefore subject to remote spoofing and DOS attacks. This example also configures a number of tracing options for routing protocol events and errors, which can be good indicators of attacks against routing protocols. These events include protocol authentication failures, which might point to an attacker that is sending spoofed or otherwise malformed routing packets to the router in an attempt to elicit a particular behavior. Okay, so it looks pretty easy. It's just going to be protocols, authentication key, and it's kind of interesting that it looks like it's not done at the interface level because I only want to do it across one link, so it looks like it's going to drop the connections to the other ones. Let's go ahead and do that, and if it drops the connections to the other ones, that'll be a good learning experience. Okay, I'm not sure which interface it is, but I just want to see if I've got the option under interface. So let's see where the help said it was. Authentication dash key. Okay, this is interesting. I don't see where this is. It says that it's just under Edit Protocols ISIS, which is where I am. But I don't see anything for authentication. Let's try it under the interface. Family ISO rather. Okay, so we've got information here about authentication with ISIS. All ISIS protocol exchanges can be authenticated to guarantee that only trusted routing devices participate in autonomous system routing. By default, ISIS authentication is disabled on the routing device. To configure ISIS authentication, you must define an authentication password and specify the authentication type. You can configure one of the following authentication methods. Simple authentication uses a text password that is included in the transmitted packet. When receiving routing, the receiving routing device uses an authentication key password to verify the packet. Simple authentication is included for compatibility with existing ISIS implementations. However, we recommend that you not use this authentication method because it is insecure. The text can be snipped. So just as we saw that with OSPF, you could see the plain text clouds being sent in the packets when I did a monitor traffic on the Juniper. That happens in ISIS as well if I can figure out a way to enable it, which right now I cannot. The authentication and no authentication statements must be configured at the same hierarchy level. Configuring authentication at the edit protocols ISIS interface name hierarchy level and configuring no authentication at the edit protocols ISIS hierarchy level has no effect. Okay, so it's telling us right there where to go. So let's try that. Edit protocols ISIS interface, and then before we do that, let's do a show int description. Like match R3. Okay, so that was the right IP, sorry, the right interface. Okay, so now hopefully we have, nope, so we still don't have any authentication commands available. Okay, so I do see options for authentication now if you specify for which particular level. And that kind of makes sense if there's multiple packets per one for each level. Having to pick the level you're applying it to makes sense if it's required. So let's try this hello authentication key. Okay, so this is going to be a plain text password. Let's go with clouds. Let's do the same thing for level 2. Okay, so now let's see if the messages here specify authentication at all. So I saw something about absorbing a hello from 000, which I believe is the interface going to R4 on this one as well. You can check that though. Nope, it's going to be 001. Okay, so here's information about 001. Let's see if that adjacency is still up. And it looks like it is, interestingly enough. All right, let's try just seeing if any filters match. So let's do a monitor stop. And then monitor start, T-shoot, ISIS. Okay, and then we'll do pipe match key. All right, I don't see anything popping up for key, so let's try authentication. Let's just do auth. Okay, and I don't see anything for that either. So let's try just matching GE001. All right, and I think I will eventually see something on this. Yep, there we go. So a hello has been absorbed, which is interesting because it did add that key on there. So I'm surprised it's able to be successfully absorbed. Yeah, we can see we have a authentication key on both levels. So one thing that was interesting to note in the last video, I tried to determine what IP protocol number is assigned to ISIS. But of course, we know that ISIS is not an IP protocol, so it's not going to have an IP protocol. Okay, so yeah, this isn't what I need to see. So let's see if we can do a monitor stop. Okay, and then do a monitor traffic no resolve. Interface GE001, matching ISIS, and get those hellos. So I don't see anything. Let's try rolling this back. Or let's try it on .0. Okay, it's interesting that I'm not seeing anything because we were getting these messages here. Oops. So here's an interesting lesson in how ISIS works. So after this part, we've got the area ID. So one thing you'll notice is if I do a show ISIS adjacency, I've only got level 2 adjacencies. I don't have any level 1 adjacencies. Well, the reason for that is because I accidentally left out a series of 4 digits here that was meant to specify the area. So instead, I specified the area here. So this router 4 is in a different area than all the other routers. So it's only able to form a level 2 adjacency if it's in a different area. So let's change that so that it's in the same area, and we'll see that it can form both level 2 and level 1 adjacencies if it's in the same area. And it will do that unless you explicitly configure it to only form one type of adjacency. Okay, so now if I do a show IS adjacency, we will see that it's got level 1 adjacencies as well. Okay, but we're still not able to get traffic. Okay, now we can get traffic. Let's try matching ISIS with a dash. Okay, let's try it with an uppercase. All right, so let's look up the documentation. Okay, yeah, so I should be able to do, for my expression here, replace expression with one or more of the match conditions. So maybe because it's not in quotes. Nope, but it's still, for some reason, not able to match on that. But you can see it is a valid message. But you can see if I don't include it, I do get ISIS traffic. So obviously something is going very wrong. All right, let's take a look at the Wireshark capture. And see if there's a field for the password. Okay, so I don't see any passwords. This is level 1, and this is a level 2. Yeah, I don't see any fields for passwords. Okay, so clearly there's some kind of issue on router 4. Okay, maybe we'll try setting the type. Okay, and we'll set it to simple so that we can see why it's important not to have it in simple, because it will show up in the Wireshark captures. All right, and hopefully the Wireshark capture is still going, and we can see a new field added for the password. So nothing in this message. This is a level 1 and 2 message. Okay, so let's look at messages that source from a particular MAC address. Okay, so let's figure out which MAC address we want to look at. It's going to be show int description, pipe match R3. So show int. Okay. All right, so this isn't the correct way. Let's do MAC equals. So this is IP. Let's try MAC equals without quotes. Okay, so works without quotes, but for some reason I'm not able to get um, here we go. Aha, perfect. ETH.source equals. Oops, and it doesn't need quotes. There we go. Now we're filtering out. These are all the messages sent from router 4 to router 3. So if there's going to be a password in these messages, it will show up in these, but it might not show up in the others. In fact, it will not show in the others. Aha, here we go. So authentication. There we go, clouds. So showing up, this is a level 1 hello message. So let's see if it shows up in the level 2 hellos. Nope, so it's only showing up in the level 1 hello, which is interesting because we did have it set up for each of them. Yeah, that's interesting that it's only in the level 1 for now. I wonder if it's because, yep, it is. So if I do show configuration, pipe display set, pipe no more, you can see I've only included the authentication type from level 1. So in order to have authentication working, you need both the type and the key. So let's add the type for level 2. We'll do simple again. Okay, so now the level 2 messages, we can do end-to-end ISIS dot here we can do hello. Now we've only got hello messages, but I'm not sure how to get. Okay, well, we can just have them all. Nothing wrong with that. So let's go to the bottom, and now, yep, here's a level 2. And now we've got authentication. So we can see it's not too hard to add authentication, but you do need to specify the type as well as the key. All right, so let's see if our Wireshark or if our on-box monitor traffic is now picking up that plain text. So nothing yet. Aha, so you can see, yep, but it looks like it's cut off a bit. So you don't get the whole thing, you just get CLOU. Oh, I wonder what happened to the DS. But this is enough to demonstrate that. So as one final step, let's change that type to MD5, and then we'll see a change here from clouds to just a secure MD5 hash. So I'm going to restart the capture. Looks like it stopped capturing. And then I'll stop this. And then I will stop the capture. All right, so now I will change that. Okay, and now we're going to change the type. We can do it just for level 1s. Okay, so now when I restart the capture, we'll see that showing up as an MD5 hash. Oops, and I'll do a filter out so that we're looking at the correct packets because we won't see it on the other side. So ETH.src. There it is. Oops, so we still got clear text, even though it's not set up for clear text. Oh, but it must be because this is a level 2. Yep, it was level 2. So yep, here we go on level 1. We've got a message digest HMAC-MD5 instead of level 2, where we've got clear text. So yeah, that's perfect. Now let's see if router 4 has any adjacencies to router 2. Aha, so it is missing the adjacencies. That makes a lot of sense because router 2 does not have these passwords set up. All right, so let's get these set up on router 2. Sorry, router 3, I mean. Okay, so now hopefully we'll see these come up. Aha, yep, so now they're up right away. Okay, so I think that's enough for this. So hopefully I can do a after work video today and just finish up this topic by configuring OSPF version 3 for IPv6 and doing a similar thing, setting up authentication and looking at the traffic. So thanks for watching, and I'll see you in the next video.